All right, 2.2 functions and graphs. So previously, I kind of real quickly mentioned this term function. So today we want to look at it. There are special types of things for us. And so we want to kind of get into them a little bit closer and see what's happening with them. Okay, so let's put up some definitions. So our first one is called the domain. Okay. This is our independent variable, also known as the input, and this is typically the x values. Okay, now we don't always use x, we use other letters sometimes, but when we're looking at graphing and those types of things, we use x and y. And so our x values is what we plug in to other things. We plug in those first and say, hey, this is what it is, and we determine the y value from that. So that is considered our domain there on those. Our range, this is our dependent variable. And this is typically the y values. Okay. Now, you can look at it, the domain is what I plug in. The range is what I get out after I plug that in for those. And so that's what we usually do. We usually plug in for x, and we see what y value we get out when we plug that in for those. So that's why they're typically the domain, the range. Okay. Next one is a relation. And a relation is any set of ordered pairs. Now, we just briefly talked about ordered pairs last time. That's what you're creating when you plot a point. We had those x and y values. That is an ordered pair for those, okay? And so it combines the x and the y as a single location on our graph. That means x has to be related to y somehow, some way. We don't always know the way. Sometimes we're just given the ordered pairs, but sometimes we do, and that's when we're given equations and things like that, okay? So that is just a basic relation. So when we have the x and y as an ordered pair, that is a relation. And then our last definition here is function. So this is a relation. So we know that it has ordered pairs. So a relation in which every member of the domain, so all of my x values correspond with exactly one member of the range. Okay. So that means we have every x value there being used, and every x value goes to some y value, but it can only go to one. It can't go to two different ones. Okay. So it would be like having people in classrooms. People are our domain, classrooms are my range. We have to put people into the classrooms. Now, they don't have to go into every classroom, they just have to go into a classroom. But a person cannot be in two different classrooms at the same time. That's not possible. So that means it would be a function, okay, for those. And everybody has to go into a classroom for that as well. So we have those pieces on that, okay? Now, one kind of side note here, I'm just going to put here function notation. We may talk more about that later on, but you're going to see it here today as well. So if it does come back up, I'll just remind us. The function notation, you're going to see this f(x) like so. That's how we write that. That is not multiplication. That is f of x is how we read that. Okay. This here is f of x. And it means that we have a function with variable x on it. Okay. And so that's how you want to recognize that. So when you see that piece, see f of x there written like so, that tells me I have a function with variable x on those. Okay. All right, so let's go and see what this section is going to give us moving forward. All right, so examples. All right, number one. Is the following a function? All right, so we're going to have different parts here. So part A, we're going to have this domain and range. And in our domain, we've got -1, 0, and 1. In our range, we have 2 and 3. And then here, we're going to have these numbers, these arrows going from those. Okay. So if we want to know if this is a function, we look at our x values. The first question is, do all of the x values have an arrow coming from it, our domain? Everything in the domain have an arrow coming from it. Yes, they do. So that's good. That's step one. Step two, is it only one arrow from each of those? Here we can see only one arrow. So yes, this is a function. Okay? Because that tells me that every x value is going somewhere, and they're going to different places. Now it doesn't care that two of them are going to the same place. It only cares that each one are going somewhere. Okay. So let's look at another one there. So domain, range. 5, 10, and 15. 1, 2, and 3. So we can go 5, 10, 15, like so. All right, so again, when we look at this, we can see all of them have an arrow coming from the domain. So yes, they all have an arrow. Does any of those in the domain have more than one arrow? But we see here that the 10 has more than one arrow. That 10 is trying to go to two places. It's trying to go over here to the 2 and to the 3. So no, it is not a function because it is going to two different places. Okay, it's a relation, but it's not a function. All right. All right, now those first two are what we call mapping diagrams. And so we have different ways of representing things. That is one way. Another way is to look at just ordered pairs. So here, what if we have a set of ordered pairs? And so I want to know, is this a function again? So we're looking to see, is there an x value, a domain, that goes to two different places? All right, so we have 1, 2, -1, 5, 1. Well, I've already seen 1 before. 1 went to 2, and now 1's trying to go to 3. So that tells me, no, not a function for those. Okay, because of that. Now, if all of those x values were different, it would be yes. But in this case, we saw two x values that were the same, so not a function. Right. All right, here is a graph. So what if we're looking at a graph? How can we tell, is it a function or not? Now, we could try to look at all the x values, but the easy way to do this is to do what we call a vertical line test. And that means that we draw vertical lines on our graph and see, does those vertical lines hit my graph, meaning the blue line, more than once? Okay? So we draw a vertical line. Well, it only hits once. Draw another one. It only hits once. Draw another one. It only hits once. And it doesn't matter where we draw a vertical line. Every time it's only going to hit once. So since that's the case, then yes, this is a function. Yes. Because of the vertical line test. Now, the other ones you're not going to have on a test, but if you had this graph on a test, you would say yes. And then the reason for this would be by vertical line test. Okay, or because of the vertical line test, passes the vertical line test would be how you could phrase that. Okay. All right, so here's another graph. We want to know, is it a function? So again, if we do our vertical line test, come over here, we do a vertical line test, we see, well, that hits twice. I do not need to do any more vertical lines. I see that it hits twice. It only has to do that one time. Hits it twice, anywhere. This is a no by vertical line test. Okay, so this test. All right, so that's what I would be looking for there on an exam when it comes to those pieces. Okay. All right, so those are different ways, different representations on how they could present, is it a function or not? All right, the next thing that they're going to ask is they're going to say, find the values for f of x equals 2x squared minus 3x. And then we're going to have a bunch of different problems. We're just going to do one at a time here for these, all using that same function each time. Okay. All right, so our first one, keep it real simple here, f of 0. F of 0. Start my marker. All right, so what that means, notice I replaced this x with 0. So everywhere in this equation, I'm going to replace x with 0. And then work that out. Okay, so 0 squared is 0, that's 0, 0, and 0. Okay, now again, I understand that you have calculators, not a problem. I do need to see at minimum that you plug that in. Now, if you want to work that out by hand and show more work, that's fine. But you need to, at very minimum, what you see on the board is what I need to see on an exam. All right, so f of -1. 2 times -1 squared minus 3 times -1. So again, you can plug that in the calculator if you want it. But if we work that out, -1 squared, that's +1. 2 times 1 is 2. And then -3 times -1 is 3. So 2 plus 3 is 5. Okay? So So that's how you would work that out. All right. Again, this is just the minimum that I'm showing you. You can show more steps on there. If I walk through that real fast with you, let me know, set up a meeting with me. I'll talk through that, show you all those little details. But again, you do have the calculators that will do that work for you. All right, and then f of 2a. So sometimes we have letters that we put in there. And so let's look at that real quick. So 2 times 2a squared minus 3 times 2a. All right, now I'm going to show more steps on this one, because you can't just throw that one in the calculator because of the a. All right, so when we square both these things. So now we've not touched this 2 in the front. So I'm squaring the 2, squaring the a. So 2 squared is 4, a squared is a squared. Negative 3 times 2 is negative 6a. But I still have this 2 on the front here. So 2 times 4 is 8, a squared minus 6a. Now this has a square and this does not, so they are not like terms. So that is all that we can do there for that piece. We have simplified as much as we can on that. So be prepared for those types of questions. We do have some variables in there as well, okay? All right, last thing here, we're going to graph the function. Okay. And so we just do one f of x equals 2 minus the absolute value of x. All right, so we learned in 2.1 there that we're just going to do a table of values, x and y. And we saw with absolute value, inside the absolute value, if we have anything added or subtracted, we need to be careful. So here we look inside our absolute value, but there's nothing added or subtracted, which is good. So that means that I can use 0, -1, and +1. Remember that if there is something in here, we do the opposite. So x plus 2, we would do -2 in the middle. Or if it said x minus 2, we would do +2 in the middle for those pieces. But in this case, there's nothing inside the absolute value bars there, so we can do our 0 in the middle. All right, so we need to plug those in. So we get 2 minus the absolute value of -1. The absolute value of -1 is +1, so that's 2 minus 1, which is 1. The absolute value of 0 is 0, so 2 minus 0 is 2. The absolute value of 1 is 1, so 2 minus 1 is 1. All right, so now we can graph that. So remember, we always start here in the middle with absolute value. And so we need to go. So I got to put my lines there. So 0, 2. And then we can plot the others. So 1, 1, and -1, 1. And then there's our graph. It still is that V shape, even though the V is flipped upside down with those. Now, all the same rules that we learned in 2.1, we can apply here in 2.2 when it comes to the graphing. The only difference is instead of y, we have f of x. Everything else is exactly the same. So we treat it exactly the same. Okay? All right, so those are the things that you want to look for there when you're looking at this section for functions, what a function is, the domain, the range, plugging in, and graphing those pieces.